We got a force of 40 Newton being applied. We need to find the moment at point O, which is here. That's the point O. So I can use a force line and try to find the perpendicular distance, which seems a bit difficult. Or what I can do, I can divide it in two components. One component is this one, which is my y component, and the other is this one, which is my x component. So I have resolved this 40 Newton into two components. For the y one, I've got this force line multiplied by this perpendicular distance, which is already given, that's here. And for the x, I've got this force line and its perpendicular distance, which is given here. So let's look at the solution. It says here, you've got your x, you've got your y, and you've got your momentum. This one, let us look at the effect of both. This one acting downward, this is the y component, okay? Now, if I look at this force, and this is the perpendicular distance, the tendency is to rotate clockwise, okay? So therefore, I've got a negative sign here, negative sign here. And let's look at the y, the x. The x is here, which is basically being applied here. And this is my perpendicular distance. So the tendency is to rotate anti-clockwise. And is that a mistake here?
For the force, it is not, like the forces are directed fine.
Yes, I don't have any negative sign here. The force signs are right because this is in the negative x and this is in the negative y. So that's fine. I've got my negative signs here when I'm defining the force. But when I'm defining the moment, this component is creating clockwise tendency. So I've got negative here. And this one is creating, oh sorry, and this one is creating a tendency to rotate counterclockwise, and therefore I have a positive sign here. Some other moments you get a negative sign, which means the tendency of the rotation is in the resultant rotation is in this direction. Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay, let's look at this one. If the force shown here is 2 pounds, how much are the moment about point A, B, C, and D? Come on, calculate it and tell me the answer. I want the answers from you. I want you to find the moment at point A and give me the answer.
It should be like 1/3 pound feet at point A.
So is that positive or negative?
It should be positive.
Sure.
Negative.
The tendency to rotate at point O because of the force.
Yeah,
it
it should be negative. Yep, negative. It's negative. About point A, it's negative.
Is that what you're getting?
Yeah, but I converted it to feet, so my answer is coming 1.3.
Why do you want to make life difficult when it's already in inches?
Yeah, but okay.
Okay, what about moment at point B?
2. Positive 2 pounds per inch.
4. It will be 4. Because it looks like it's a 2-inch.
It is 2, sorry, it is 2, yes.
Yeah.
There
So
would be
it would be
4
4
pounds per
pound
inch.
inch.
Yeah, but
Or
look, the moment I'm calculating moment at point B. Okay, now this point B is outside the object. Okay, so it doesn't matter. You are trying to calculate the moment at a point outside the body. All you need to know is the force line and the distance, perpendicular distance from that point. I've seen many people getting confused that how come the resultant moment is outside the body. Okay, so the B is that. What about moment at C?
So negative 24 pounds.
negative 24 pounds.
Yes. And
Yeah,
then at D.
The 0.
at D it's 0 because
Is 0,
D
sir.
is on the
D is 0 because
So D is
next
on the
it's
line
line.
of
long.
action of force.
On the line of action of
It's
force.
on line of action. So
Yes, there's no perpendicular distance. So which one is wrong out of those?
Sir, B.
Third one. About C.
B is wrong.
yeah, it should be negative 24.
Yes, sir.
Okay, which
Yeah.
else is
Moment
wrong?
about C.
Sir, A and C should be negative because they both tend to be clockwise.
Yes.
So A should be negative, and you're saying C should be
It's-
negative. What about B?
Sir, it is anti-clockwise.
B is anti-clockwise, so B
Okay.
won't be.
But okay, that's fine. So let's move on.